Hello, welcome to Complete SQL Bootcamp course from the instructors of Creative Online School. In this course, you learn basic and advanced SQL with hands-on practical examples. For learning SQL, you will utilize the most popular and widely used database, MySQL. We'll also dig with PHP and Python, and we'll do some practical project with MySQL, PHP and Python. At first, we'll configure the SQL environment. PHP and MySQL Workbench both are popular. We'll show how to install and configure these environments. In the basic SQL part, you will be familiar with basic SQL queries like create, insert, update and delete. You will also be familiar with select statement to get or retrieve data from database objects like table. And you will also get knowledge about MySQL table storage engines like ISM, MyISM, heap, memory and others. And in the advanced SQL part, you learn about the joining part, one of the most important and crucial of database and SQL systems. You will also learn about math operations, string operations, group by operations, subqueries, transactions and sequences. In the PHP part, you will learn the basic PHP and advanced PHP, and you will do a practical project using PHP and MySQL. And in the Python part, you will understand some basic Python elements and you will dig down with advanced Python. You will also do a practical example with Python and MySQL. And finally, if you are not satisfied with our course, we request you to refund your money within 30 days of your enrollment without asking any question.
Hello and welcome to Learn MySQL with Justin Posey, brought to you by CreativeOnlineSchool.com. A little bit about me. I have 9 years in web development, and my specialization has been in MySQL and PHP. There are other courses available at CreativeOnlineSchool.com. In this tutorial, we're going to go over a basic introduction of MySQL, how to install MySQL Server, PHPMyAdmin, and MySQL Workbench. We're going to teach you how to create databases and tables, how to import and export information from those tables, how to input, retrieve, and manipulate data with SQL, and some more advanced SQL techniques for those who want to get the most out of their system. Well, let's get started then. First, a quick aside about pronunciation. As you can tell, I've been calling it MySQL. That is the correct pronunciation. However, it is also commonly called MySQL. If you hear it called that, don't be confused. It's the same thing. So what is MySQL? Well, MySQL is a relational database management system, or RDBMS. According to a poll by Dell, around 90% of the 300 companies polled actively use these systems in their businesses. So as you can see, the RDBMSs play an important role for almost every company. MySQL is one of the most widely used of the RDBMSs in the world. According to the same poll, 41% of the companies were using MySQL, putting it in the top 3 along with Oracle and Microsoft SQL Server. So now that we know it's important, the next question is, just what is a relational database management system? Let's break it up into 2 parts. First, a database management system is simply a system designed to allow you to store and retrieve information from a database. For example, let's say you wanted to store a list of reservations. A database management system would allow you to put that information into a database, and it would store it for you and keep it available so that you could retrieve that data at any time. However, you can only pull out what you put in. Now, a relational database management system does the same thing, but it uses a particular structure for storing the data called the relational model. This model allows different pieces of information to connect to each other in a meaningful way. For example, if you look at the image on the right, you can see that there are 2 different sections of information. But despite these being stored separately, you can produce a combined section of the information. This is possible because both sets of information have something in common, the activity code. That commonality is what relates them. And storing information with those commonalities is what makes the database relational. So how does MySQL store and retrieve data? It uses something called the client-server model. In this model, the database typically resides on a server and is accessed via a client through the internet. A client can be an interface for direct manipulation, such as phpMyAdmin, or it could even be a website, application, or program which operates behind the scenes. Now that we know what a client is, let's talk about how a client communicates with the server. To do this, it uses something called SQL, or Structured Query Language. This language can be used to define, update, and query the database. A query is just a term from the set of instructions sent. Like any language, SQL has a specific set of syntaxes that when sent from the client to the server can then be interpreted by MySQL so that it can take the appropriate action on the database. A quick example of this syntax would be something like select name from person where age equals 21. We'll get into the actual syntax later in the course, but for now, that's how it looks. And the best part is that SQL is used by virtually all relational database systems, so you can use the same set of instructions no matter what your environment is. That's it for the introduction. In the next video, we will go over the different types of data that can be stored within MySQL. Welcome back. In this lesson, we're going to be learning how to install some of the programs required to use MySQL, as well as some we're just going to be using in this lesson. The first two we're going to install are MySQL itself and phpMyAdmin. Fortunately, we can get both of these in a single package called XAMPP. If you go to the link provided, you will come to this page. Now we could sign in with Facebook or Google, but I choose to just use the alternative download, which will take you to this page. You'll quickly have a pop-up which will ask you to save a file. Click Save. We could watch their installation video, but I'll explain everything you need. Now, as you see, this is downloading. I'm going to cut a little bit out here to save some time. Now that it's all downloaded, we just have to open the file, and it'll ask us to run it. You may get a little pop-up that warns about possible slowing down of the installation due to an antivirus, but it doesn't really have much of an effect, so just click Yes. Then you will click Next. And in here, we don't really need most of these things. We're just looking for MySQL, so we're going to uncheck all of these. Remember, we also want to get phpMyAdmin. We're going to click Next. And you can select the installation folder. By default, it's just C XAMPP. Don't have to click to learn anything more, so let's uncheck that. Now it's ready to install. Unpackaging. And once again, I'm going to cut to the end to save you some time. Once that's loaded, it'll take you to the Finish page. And yes, we're going to go ahead and launch the control panel. It'll ask us to choose our language. And then you're going to see this easy to navigate panel. Let's go ahead and start Apache and MySQL. That's it. We actually have the prep work for a database already. And not only that, because we installed phpMyAdmin, we have a way to see it. To open phpMyAdmin, simply go back to your browser and type localhost phpMyAdmin. That'll bring you up to an interface where you can see that we now have MySQL installed and some test databases that come default on the system. We're not going to go into actually using this just yet, since this is just an installation video. We'll move on to the next thing. If you're not using Windows, then the installation instructions provided already may not tell you all you need to know. For XAMPP, if you're on a Mac, you can use the download location I provided in Figure 1. After downloading, just open the downloaded file. It should be named the same as I listed here. Drag and drop the XAMPP folder into your Applications folder. That should complete installation. And then, to start XAMPP, simply open the XAMPP control by going to /applications/XAMPP/XAMPP in your control finder. And from there, you can start Apache and MySQL. If you're on Linux, then you will need to use this location for download. After downloading, you're going to need to change your permissions on the file so that it can be executed. I provided the command to do that here in Figure 2a. After that, run the installer. The command for that is in 3a. Once it's running, you can just follow the prompts to install. It should be just like the Windows version. After installation, to start XAMPP, enter sudo /opt/lamp/lamp start. That'll load everything and should get you back where we were in the video. Speaking of videos, that's it for this one. We'll continue our installation with SQL Workbench in the next video. Next, we're going to install MySQL Workbench. It's similar to PHP-MyAdmin, but also has a few bells and whistles that we may want to utilize. Let's go to the download link, and you'll be taken to this page. Now, if you read carefully, you'll see that there are actually a couple of other things that need to be installed in order for MySQL Workbench to work. One of those is Visual C++, and the other is Microsoft.NET. I already have .NET, and you may too, but we're going to need to install this one. If you need both, the installation is the same. So let's click here. It'll take you to this page and ask to select the language. Next, it'll ask you whether you have a 64-bit computer or 32. Click 64 if you have that, which is what I do. Click Next. It's going to start your download. It's fairly small. So now that that's downloaded, we'll just click on the executable, click Run. It'll open up and ask you for you to agree, install, and it only takes a second, and now you have it installed. Simply close this. Let's go back to the original page, and now we're ready to install MySQL Workbench. It uses something called the MySQL installer, so we're going to go ahead and download that from its download page. If you scroll down a little further, it'll have two different options for you. Let's use the smaller one, as it doesn't download anything we don't need. Scroll down. You don't have to use or sign up anything. Just click No Thanks, Start My Download. Save file. It too is fairly small, so let's open it. You may get a small warning, but this is from Microsoft, it's harmless. Click OK, Run. It may ask if you want to upgrade. Just say no for now. I accept. Next. Now we only want part of this, so we're going to go to Custom, Next, Open Applications, MySQL Workbench, Continue Opening, and select MySQL Workbench. Now if you don't have all the necessary components, this will be grayed out and it'll tell you what you're missing. Just click over here once you're done, and click Next. That's it. Now we're ready to execute. And it's begun the installation. Once the installation is complete, just hit Next, and it'll ask if you want to launch. We will. And that's going to bring us to the setup. Now, to create a new connection, simply click the plus right here, and you'll see the connection window. First, let's give it a name. Let's call it Example Database. Next, we have the connection info. If you're connecting to a server, you may have to modify this a bit to connect to the right place, but for now, we're connecting to the instance we just made, which is local, so this is all already correct. Next, click OK, and now we actually have one set up. There may be a short warning, but it's just telling you that Workbench and the MySQL version we installed are different. It's no big deal. And now you've created the connection so that you can see the database that we created earlier. Now there's nothing in this database yet, but we'll go over that in our next video. For now, let's just talk about the differences in installation if you're not on a Windows machine. If you're on a Mac, you can get the same file we did earlier at the provided URL here. Once it's downloaded, double-click the downloaded file, and then drag MySQL Workbench icon onto the application folder. Once that's done, you can now launch the MySQL Workbench from the Applications folder, or from the command line. If you want to do it from the command line, the command is below. If you're on Linux, then you can get the download from Workbench by selecting your system from the Selected Operations System menu, but you can also get it automatically. All you have to do is type sudo apt-get update, hit enter. Quite a few things may load depending on what updates you need. Once that's done, type sudo apt-get MySQL workbench, and it should install it for you. That's it. Now that we have all the tools installed, next time we'll go over how to create databases, tables, and columns. This has been brought to you by CreativeOnlineSchool.com. Welcome. In this lesson, we are going to go over data types. Specifically, what data types are, the most common data types, the data types that are supported by MySQL, how data types affect what you can do, and how to choose the best data types for you. So let's get started by going over what data types are. Data types are classifications for data that help to identify what kind of data is going to be stored, as well as how it will be used. What this means is that in effect, you can think of them as identifiers for the containers the data is going to be placed in. In fact, there is an easy comparison with something you are probably already familiar with. That's right. Just like the labels on these containers, data types determine what kind of information should be stored in the container. Also, just like these recycling containers, the data type labels aren't arbitrary. They matter because of what's going to be done with what's inside the container. If you put glass inside a paper container, then when it comes time to run the process, there are going to be problems. The same is true for data types. With that in mind, let's talk about what kinds of data types there are. Although there are dozens of different recognized data types, ranging from the common, like containers for numbers, to the obscure, like containers designed to store coordinates for locations in three-dimensional space, for now we're not going to be too concerned with the data types that are rarely used. We're going to focus on the data types that are most common, the ones you're actually likely to see. Those data types can be broken down into three broad categories. The first category is the numeric category. As the name suggests, these types deal with various kinds of numbers. The numerical types you are most likely to run into are integer, float, and decimal. The integer type primarily deals with whole numbers, while the floats can store numbers or numbers with decimals. However, it can round numbers and it truncates leading and trailing zeros. The decimal type is like the float type, but it stores the exact number without any rounding or truncating. The second category is called date time and relates to storing dates. The most common of these types are date, date time, and timestamp. Date stores only the date, usually in year, month, day format. Date time stores both the day and the time in hours, minutes, and seconds. Timestamp also stores the date and time, but it converts the time from its current time zone into the UTC time zone. And when you retrieve the information, it will automatically convert the time to the time zone of the requesting client. Finally, we have strings. Strings are one of the most versatile types because they can store all kinds of letters and characters, everything from a person's name to an account code that may have both letters and numbers together. The most commonly used string data types are char, varchar, and blob. These data types are a bit different from the others, as they all store the same types of information, but they store them in different ways. Char can store information of up to 255 characters in length, and it fills any remaining room with spaces, so it's always the same size. Next, we have varchar. Varchar, instead of having a set number of characters, is instead limited by the space that it is used by the data it's storing. It does not fill with spaces, so smaller strings take up less space. The maximum space used cannot exceed 65,535 bytes. Last, we have the blob. Blob data type, which stands for binary large object, can store up to 65,535 characters. However, it stores the text as binary data, ones and zeros, so it has to be converted back in order to be readable, and that requires more processing. Well, we've covered a lot of information so far, so let's pick up the rest of the lesson in the next video. Picking up where we left off, now that we know about data types, let's talk about how they relate to MySQL. MySQL supports all of the common data types and categories mentioned, as well as having specific categories for spatial types, and it has recently added the JSON data type, so it should cover almost any data type you're likely to have. Beyond that, it also allows for more efficient storage by supporting size-limited types. An example of this can be seen in the different scales for integers, which range from the tiny int with a max number of 255 all the way to a big int which can store numbers of over 18 quintillion. This allows you to only allocate as much space as you will actually need. Now let's talk about how choosing a data type affects what you can do with the data. We have already mentioned several ways that the data type can affect the space used as well as your processing efficiency, but let's talk about something more tangible. That is, how the type affects what you can do with the data. For example, it is possible to store a date as an int or a string instead of as an actual date, and as long as all you are doing is storing and retrieving the date, that's fine. But let's say you then wanted to order the dates so that you had them from oldest to newest. Let's take a look at what happens in the chart below. When told to order the date, the system is going to order the integer by pure numeric value, while it orders the string alphabetically. Both of these fail to give you the date from oldest to newest, but the correct types allows for getting the correct dates in the right order. So now that we know how important the types can be, let's go over how to choose the best type for you. To do that, there are three primary things to consider. First, think about what you're going to be storing. That includes both what it is as well as its length. If all you're storing are small numbers, then there's no reason to use a string or a big int. That just limits functionality or wastes space. Also, consider how important it is to keep the data exactly as entered, or if it's okay for it to be converted in some way. Next, think about how you may want to organize or report on the data. If you're storing a name and a date, and you sometimes want it ordered alphabetically and sometimes you want it ordered by date, then you're going to need two separate data type containers. But if you know you will always need it in an alphabetical list with both name and date present, then it may be okay to store them together in a single string. Be careful though, as it may be too late if you decide later on you need them separate. Lastly, remember that this is a relational database, and as such, the data may be connecting to other data. It's always much easier to connect and filter data if both parts are the same type. Well, that's it for this lesson. Next time, we will go over how to install some of the programs you will need in order to use MySQL. Brought to you by CreativeOnlineSchool.com. Hello! In this lesson, we're going to go over the differences between PHP/MyAdmin and Workbench, how to create and update database tables and columns in both PHP/MyAdmin and Workbench. We're going to go over the principles of table design, as well as go over the uses of users and their permissions. We have already went over how to install both PHP/MyAdmin and MySQL Workbench, and later on we will be demonstrating how to do some basic tasks on both. But for now, let's talk about some of the core distinctions between the two. First of all, MySQL Workbench is a desktop software. This means that it is installed on your local operating system, and it can connect from there to different servers. This is helpful if you need to manage databases on multiple servers. PHP/MyAdmin, however, is a web-based tool, and is designed to be set up on the server itself. This means that it can be accessed through any browser and is not limited to a particular local device. This is helpful if you often use different devices or have multiple people working on the same server. Also, it's worth noting that PHP/MyAdmin is a bit more streamlined and is often easier to learn for new users. MySQL Workbench, on the other hand, contains some added functionalities like server administration and database modeling, which can be very useful when trying to visualize complex data relations. Okay, so now let's get started by showing how to create databases, tables, and columns. We will start with PHP/MyAdmin. Now remember, to open PHP/MyAdmin, just open a browser and type localhost/PHP/MyAdmin. If this was installed on a server that wasn't on your home machine, you could just put the server's address there instead of localhost. Next, to create a database, we simply go over here to the left and click New. Choose the database name. I want to call it Person. And then choose the collation type. Now, collation's a little bit of a tricky subject for people because there are a lot of options. But basically, collation just sets the language that your data is going to be interpreted in. And most people don't know the language that their data is going to be in, because a person's name, if input, could be in German, Spanish, or Chinese. So what we need is a good general way to sort through all of them. Fortunately, we have a good option, and it's what I use for most of my data. It's called UTF-8 MB4 Unicode CI. This uses Unicode formatting in order to sort things so it doesn't care what language it's in. Case insensitive just means it treats capitals and lower cases the same. So let's create our database. Now that we have a database, it's prompting us to create a table. You can set the number of columns and the name right here. Now every person has a name, so our first table we're going to call name. And I'm only going to use 3 columns for this because we're going to keep it pretty simple. Now click go, and it brings us into where we need to input the information. Remember those data types from earlier? This is where they come in handy. So our first column, I'm going to call it ID. It's always useful to have an ID because that way you can reference it in your other tables. And this ID is going to be very special. It's going to be our primary key. You select that here, primary. Now what this is going to do is it's going to say that this is the key thing that we're going to use to access other data types. So click go. Now as an ID, we're going to want to increment it so that it's always unique. You don't want 2 IDs to be the same. AI just stands for auto increment. Next, every name has 2 parts, so we're going to call this one first name and this one last name. We could do middle, but we're just keeping it simple. Next, we're going to change our type. There's no point trying to use an integer to be a name, so we're going to use the varchar. Now we have to set how many characters we want to use. A first name is not too likely to be over, say, 15 characters, so I'm going to put that. And the same for the last name. You could increment it if you think it'll be longer, but for now, this is what we'll use. Now, if we wanted, we can set default values. For first name, for example, we could choose, if no one inputs the name, to set the name as John. And for the last name, if no one inputs it, it'll say Doe. You could also default it to be null or default it to the current timestamp. Next, notice you could actually set your own collation for each variable, but we're just going to use the one that we set for the whole table. For attributes, it's going to change a little bit depending on your type, but the primary thing for integers is whether or not they're signed or unsigned. By default they're signed, but that allows numbers to be both negative and positive. For an ID we don't really need that, so we're going to choose unsigned. This also allows us to go up to the full number in the int range. If we wanted any of these to be null, we could select to allow them to be null. So let's click Save. And now we not only have a database, but we have a table, and that table has 3 columns: ID, first name, and last name. That shows you how to do it in PHP-MyAdmin. In the next video, we'll go over how to do the same thing in MySQL Workbench. Now let's go over how to do the same thing in MySQL Workbench. First, choose your connection. If you have different databases, you can select them here, but we only have one for now. Remember, this is just a warning about a version difference. Over here, you can see that we already have the person database we created earlier. Now I'm going to create a new one by right-clicking and clicking Create Schema. Because this is a desktop application, it allows us to do things like right-click, which we couldn't in PHP-MyAdmin. We're going to give it a name. Since we already have person, we'll back up a step and we'll call this one Customers. Oops. Next, we'll choose the correlation type. We'll choose the same one, UTF-8, MB4, Unicode CI. Click Apply. Workbench does something interesting. It shows you the query that's going to be run before it runs it. This can be useful if you're trying to learn how they're working. Click Apply. It's executed, so now we hit Finish. And now you can see over here that we have a customer database. If I double click it, I can go up here and click Create New Table, and that'll give us our form.
Now, I'm going to skip this for now because MySQL has the visual way to do this, which is one of the things that make it more unique, and it uses the same form, so we'll see it in a moment. For now, instead of this, we're going to click File, New Model, Add Diagram, and it's going to open up this page. From there, simply come over and press the table button, choose a place on the map, and now we've placed a table. If we double click it, we'll see that same form from earlier, and you can actually enter the table name and the columns at the same time. Since we already had person before, we'll name this one person. We'll give him an ID, which is an int. It's already selected that for us. We'll set it as the primary key and not null, and set its auto increment. Over here, we'll give each person a name, and it's selected varchar45 for us. We can change these things if we want. Each person, if they're a customer, is also going to have something they bought, so we'll say purchase. That should do for now. So if I get out of here, you can see that we have a representation of a table with 3 columns in it. Next, we're going to create one from a template. It has a few already loaded, and this will just save us some time. Now I'm going to go ahead and add a primary key since it doesn't have one. We'll call that person ID, since we're going to try to connect these in a moment. We'll set it as an int, primary key, non-null, and auto-incrementing. Now we have these two tables, and it can actually help us visually connect them. And the more tables you have, the easier it'll be to see how things connect if we do it this way. Also, it has a very handy feature of if you select down here and you select 2 tables, it'll automatically create a table that has the things they have in common in it. In this case, it has the ID from person and the person ID from user copy 1. These are called helper tables and can help you make your queries a little bit easier to use. Now that we have some tables, let's save them. You come over here to File, click Save Model. You can locate it anywhere you want. I'm just going to call this Model 1 for now. Click Save. Now that it's saved, we can come up here to Database, Forward Engineer. All this stuff will just stay the same. And it should be processing. If everything goes well, those are checked. We close it. And now, when we go back to look at our customers table, we can expand tables and see that we now have person has user, and user tables. All 3 of them were automatically created for us. And if we expand, we can see that inside there are columns for ID, name, and purchase. Well, that's how to make databases, tables, and columns in PHP MySQL. In the next video, we'll go over some principles on how to best structure your tables so they can be used together. Now that we have covered how to make tables, let's talk about some principles of table design. That is, some things you should think about when deciding which columns will go into which tables. The first and most fundamental is the idea of avoiding redundant data. Redundant data is what we call it when you're storing the same data multiple times or in multiple places. This wastes space and can lead to slowdown or even data inaccuracies if one gets updated and the other does not. Here's an example of redundant data. We are storing Dave's name, address, and email multiple times, which wastes space and makes keeping it up to date difficult. The second thing to think about is how the data will connect and include what's necessary to connect them. We call these keys. You already saw how we set an ID to be a primary key, and that's the primary way that data is going to be connected to other tables. So what does that look like? Well, let's try and fix our table here. First, to avoid redundant data, we keep info about the person in its own table with the primary key of ID. Next, we create the table for purchases. Notice the column on the right called Person ID. It stores the information needed to identify the correct person. We call these foreign keys, and it allows this data to be connected back to the primary key in the person table. Our last guideline is related to the other two, and that is that you need to think about what you're going to do with the data and how you're going to want to view it. This will help you to determine which tables need to connect to each other and which may be fine on their own. An important part of this process that we haven't currently covered is what happens when different people have different needs. This is handled through a combination of users and permissions. There are three main uses of users and permissions. First, it allows you to determine what actions a person can take on a database. You may not want everyone who can see the data also being able to enter new data or update it. The four primary permissions are read, write, update, and delete, and they allow a user to do exactly what you would expect. Next, you may want some people to be able to access some of your data, but not all of it. This is common, especially if you have sensitive information in some tables, but that's okay because permissions can be set per table, so you can choose to allow access only to what you want that user to have. And finally, a user can also be set so that they can only access information if they are making the connection from a specific place. So you could only allow access from your office, or only allow connections from other servers that you own. This greatly helps with security. Let's quickly go over how to create new users. First, select the database you want that user for. We did person over here, so I'll check that one. Go over here to privileges. That'll show you the users that currently have privileges. We can choose to add a new account. Select the username. I'll name mine Justin. A percent means that you can connect from anywhere. If you have a specific location, you'll need to enter its IP. You can have a password, which you'd need to retype, but it'll also allow you to generate a random one for extra security, and we're going to do that. You can see that it's selected to grant privileges just for this table. If you wanted it everywhere, you could check here. Now, all of these here on the right are pretty much things you're only going to want your server administrator to have, but for generic users, you're only going to be using data permissions. Select, insert, update, delete. File also helps if you have files that may be uploaded or downloaded. But we'll give this particular user select and update. Next, click Go. And that was created. I've now added a new user. So if we go back to person and go back to privileges, you can see the new user, Justin, has been added. For Workbench, to add a new user, all you have to do is select the table, go to Server, Users and Privileges, Add Account, select the name. You can see we've already used Justin from the one we added in PHPMyAdmin a moment ago. So for now, I'll just name it New Justin. We're going to leave it at %. It doesn't generate a password, so I'll have to make up one, and I'll use one that I choose to use, even though it thinks it's weak. It's only for a demonstration after all. We click Apply, and you can see New Justin has been added. Now you can go over to Schema Privilege, choose to add an entry. You can choose whether you want this person to have access for all the databases or just a selected one. We're going to select Customers since that's the one we created here. Click OK, and then we can select our Select, Insert, Update, and Delete privileges that we normally have for our users. Click Apply, and there you have it. We have a new user with the permissions we want. Next time, we will go over importing and exporting data. This has been brought to you by CreativeOnlineSchool.com. Welcome! In this video, we're going to be talking about importing and exporting. That is, now that we know how to create tables and structure them, how do we get our data inside or out? Well, when we do that in bulk, it's called importing and exporting. Importing is taking data from an outside source and in a particular format and loading it into an existent table. Exporting is taking data that's already in a table and creating a file with that data in a specific format. The most common file formats are called CSV, XML, and JSON. CSV stands for comma separated value, and it's the most commonly used, and it's what we'll be using in this video. So let's get right to it. In PHPMyAdmin, all you have to do is select the table. Remember, we called this one person, and its table's name was name. Click import. Select the file you want to import. We're going to click name. Now inside of name, this is what it looks like. You can see that it's encapsulated by quotes and separated by commas. This is pretty standard, and it has a different one on each line. If we scroll down, we can see that it shows us the same things. Columns separated with commas, columns enclosed with quotes. You can change these to be whatever you want, but you have to make sure it matches the file. Next, we're going to click Go. And now, if we go over to Browse, we'll see that there's actually data in our file. And that's importing data. So, to export it, we simply click Export. We don't have to select a template, but we do have to select a format. We'll do CSV again. There's also CSV for MS Excel if you intend to open it in an Excel sheet later. It can be useful. We're just doing it in text though, so CSV. Click Go. It'll automatically name it according to your table name. Click OK, and it's saved the file. It looks exactly like this one. Next, we're going to go over Workbench. In Workbench, we select Customers because that's our table here, and Person was our table itself. Click this little square next to it, and that'll let you see what's in the table. Currently, it's empty. It also gives you your export and import buttons. We're going to click Import. I'm going to go to where I have the file. It's called Customers. Open. This is a preview of what it's going to look like, but it's not actually saved yet. We're going to click Apply. It'll show you your query, handy if you're trying to learn them. Click Apply. It's finished. And now you actually have the data in the table. To export, you click Export. And then you give it a name and click Save. We already have one called that, but we'll just replace it. And now we have it exported. Now, something to be aware of is this is what the table looks like when it's exported in CSV with Workbench. It's not all new lined. In fact, it's all in the same line, and there's also no quotes. These things aren't necessary. As long as they're separated by commas, it still works, as you saw when we imported it. But different programs can export in different ways, and there's no uniform method. Well, that's it for importing and exporting. Next time, we'll go over how to manipulate data with queries. Brought to you by CreativeOnlineSchool.com. Welcome. In this video, we're going to go over an introduction to queries and query structure, cover some useful learning tools in PHPMyAdmin, as well as constructing some basic queries to select, insert, update, and delete data from our tables. First, let's start with what a query is. Queries are sets of instructions written in a language that can be understood by the database system. In our case, that system is MySQL. Queries have three basic parts: an action, a location, and a restriction. An action, or what the purpose of the query is, will begin with either select, insert, update, or delete. A location, which identifies which table or tables the action will be performed on, will be started by from and the table name. The restrictions, which is the most expansive section, covers what columns and rows of data will be affected. Most of them will start with where and the set of the restrictions. Restrictions often use operators like greater than, less than, equals, not equals, like, or not like. So let's quickly go over some of those tools I mentioned. If we select our database, you can see we already have some data in it from earlier. But up here, there are the search and insert tabs. Those will allow us to do things through a form instead of making a query. Now our goal is to make queries, but
they can help us understand what's going on. So if I wanted to insert, I can say I want to insert Smith, and then just click Go. And you can see the insert it created. This is the format it follows. And now we're on the SQL tab, which is where you will write your own queries. And that brings us to the second thing that it has that's useful. It allows you to have default formats for deletes, updates, inserts, and selects. These tools can be very helpful when you're still getting used to the whole formatting of queries. But let's start making our own. For now, I'm going to use their preset format. This is a select. It's selecting ID, first name, and last name columns from the table name where1. Saying where1 is like saying where nothing. You don't even actually have to have this, but it uses it in the default. And I'll click Go, and you see it gives us all the things in the table. ID, first name, and last name, and everything in here. Now, we can edit in line to make things a little easier for us. And if I were to change ID, first name, and last name to star, I'll actually get the same thing because star means everything. That way you don't have to list them all out. So if I click Go, I get the same results. Next, let's go back and say where first name equals James. Now, because first name is a character set, we want to put the value in quotes. That identifies that we're talking about characters. If you don't put it in quotes, it's going to assume it's a number, and we'll probably get nothing in this case. So we click OK, and it gives us only the records who have a first name of James. If we wanted instead to use a number, we could say where ID equals 1 or ID equals 4. Because these are numbers, we don't have to use those quotes. And an OR means I'll accept it if either of these things are true. So I click Go, and you see ID 1 James, but now we have ID 4 Amy. Next, we'll cover making more than one thing true. This one is either, but if we wanted two things to be true, we would change it to and the ID is never going to be the same number. So we're going to do first name again. You can also auto finish with this. Equals James. And remember when we just had James, we got 2 results. But because now we're also requiring the ID to equal 1, we only get 1 James. Next, let's change our search so that we only want the first name and last name. Let's say we didn't care about ID. I can change this to first name, comma, and when I run it this time, ID is no longer in the column. Next, let's, instead of using equals, use greater than. If I say where ID is greater than 1 and click Go, you can see that it gives me 9 results. We're missing the first ID. I'm going to go ahead and put ID back in there just so that we can see what all's going on. Now, along with greater than, less thans, and equals, there is not equals. So if I said where ID is not equal, that's an exclamation equal 4 or 5, I can click Go, and you can see we've got all of them except ID 5. That's not equals. Last, we'll talk about likes. Likes are only used for strings. So let's do first name again. Like, open a quote. We're going to enter a percent. Percent is a wildcard character. It means anything before A, and that's just the letter A. And we're going to put another percent. So any A with anything before it or anything after it is acceptable. So I click go, and now I only get the names that have an A in them. And if you wanted only the ones without an A, you can just do not like. And that gives me the others. Now, there's one thing we haven't covered yet. We've been setting everything equal to or like something we're entering. But what happens if you're looking for a comparison of data you already have? So let's say where first name equals last name. And if we do that, then it'll actually look at everything in first name and find the ones that match it in last name. And if we click go, then we'll see Smith Smith, which we entered earlier. We'll be moving along now into the next video, where we're going to do the rest of the updates, inserts, and deletes. Let's move along to the other kinds of queries. Next is insert. The primary difference between inserts and selects is that when you're selecting the table, instead of selecting from the table name, you're going to insert into the table name. The second thing is that there's two different formats you can follow. There's the one that they have here as their example, which lists the columns and then sets the values. If we were to enter values for these, and we're going to remove ID since that one auto increments, we don't actually want to assign any values there. And then we were to just replace these with Bobby Holmes. When we run this one, you can see Bobby Holmes was inserted into our database and the ID was auto increment. Now, the other format that you can use is insert into name, and instead of breaking them out into different sections, you can have set, which is a keyword, first name equal to Sandy, comma, last name equal to Meeks. And if we hit go, you can see that that also got inserted. Now, which format you use is entirely up to you. If there's only one or two values, it's often easier to use the second one. But when you're doing a big list of values, this one's much more efficient. Now we're going to move on to deletes. Deletes are one of the more interesting ones because they're very dangerous. As you can imagine, you don't want to lose your data. So it's much like a select. You delete from table and you have your where condition. Now, the reason they're dangerous is because if you don't do anything to this where condition, it's going to delete everything. So you have to be really careful what you're deleting. So it's often wise to actually run a select so that you can see the data before deleting it. So we're going to run a select, and we'll select star. And to do this as an example, we'll just say where ID equals 5. If we run this, then we can see which record we're going to delete, Sam Johnson. So I'm going to go back to the SQL, paste in the query we had, change select star to just delete. And when I run it, it will delete that record. You can see we no longer have an ID of 5 in here. Next we have updates. Updates use the format update, table name, and then it does set column equal, just like the second set of inserts we saw. So if I were to set, again, we don't have to do ID. Actually, we could do ID in this case because we're not inserting a value. Of course, we don't usually want to mess with those, but just to show you how it works, I'm going to set ID equal to 5, since I know there's not a 5 because we just deleted it. And then first name will be set to Billy, or Bully. Thompson. Now, again, your where is going to be important because you don't want to update everything. And if you ran this, it would update everything. So we have to insert our where, and we'll do where ID currently equals 10. We'll update that to 5, and that way we can see the change. And if I hit go and look at the data, you can see we now have a 5 of Bully Thompson, but we don't have a 10 because that one was updated. And that's how to do inserts, updates, and deletes. That's it for this video. Next time we will begin discussing some more advanced concepts and query techniques. Brought to you by CreativeOnlineSchool.com. Before we go any further into more advanced queries, let's talk about something that will have an important effect on how those queries run: the database storage engine. In this lesson, we will go over what they are and talk about the most common ones and their differences. And then we will show you how to change the engines in both PHP-MyAdmin as well as in Workbench. In short, database storage engines are the things that power the queries that we run. Just like you have different engines in a sedan or a race car or a diesel because of the different purposes of those vehicles, databases can have different storage engines depending on their best use case. There are 4 primary database storage engines: CSV, ISAM and MySAM, heap or memory, and InnoDB. First, the CSV storage engine. CSV storage engine, as its name implies, has tables that are really text files with comma separated values, just like the ones we were importing and exporting earlier. This allows the exchange of data with applications that can read and write to CSV format, but CSV tables are not indexed, and that can make them be extremely slow when running queries. They're mostly created just to assist with large imports and exports. The ISAM and MyISAM storage engines were designed with the idea that a database will be queried far more often than it will be updated. That is, based on the idea that selects will be what you'll run most of the time. As such, it's very fast when running those, but it can have some issues when you have frequent updates or inserts, especially ones run at the same time. This is because it doesn't support transactions. Each individual statement is run on its own, and they can sometimes overlap with each other if they're coming quickly. Also, it's not fault tolerant. What I mean by that is that if something goes wrong and your disk is corrupted or your hard drive fails, it's quite possible you'll lose everything. MyISAM is an upgraded version, and it allows for table locking and some better fault recovery to address those 2 issues, but it also requires periodic clearing of wasted space, and so is a little bit more labor intensive than the other options we have. Heap, or as it's recently been renamed, memory storage engines, allow for temporary tables that reside only in memory. They are faster than even ISAM or MyISAM. However, there is greater risk of data integrity issues because your data will be lost if it's not saved prior to shutdown. So if the power goes out or it locks up, you're going to lose a lot of your data. It's not really designed to be in long-term use. The last storage engine I'm going to talk about, and the one you may remember us selecting earlier in our databases, is called InnoDB. It was designed to address the ISAM and MyISAM issues with their transactions and their lack of foreign key support. This allows for better handling of parallel insert updates and deletes, so they're not likely to interfere with each other. However, it's slower than ISAM and MyISAM when it comes to doing select statements. As such, it can be very good for small to medium data operations, but if it's too large, it may need to be used in conjunction with MyISAM or memory, so that you can run the selects from there and then do the rest within ODB. Now that we know a little bit about the engines, let's go over how to change them. Here we are in PHPMyAdmin. All you have to do is click on your table, go over here to Operations, and you can see the drop down for Storage Engine. We currently have NODB selected, but you can choose CSV or MyISAM. Depending on the interface you're using, you may have different storage engine options. These are the ones we have for PHPMyAdmin. Next, we'll go to Workbench. To change it in here, you once again go down to your table, and just click this little wrench next to it. That'll open this window, and you can change the engine. You can see we have a few more options here. If I wanted to change it to MyISAM, I just click Apply, and you see the query, and now it's finished. They're very easy to change, and as such, you can use whatever engine you currently need. Well, that's all for storage engines. In the next video, we will go over some more complex queries, such as how to use multiple tables. Brought to you by CreativeOnlineSchool.com. Welcome! In this video, we're going to be going over joining, specifically what joining is, the different types of joins, some basic queries using joins. We'll then go over how to do multiple joins, as well as how to use the halving clause, which is used with joins. So what is joining? Well, joining is the process that allows data from multiple tables to be used. So far, we've only been running our queries on one table, but most of the time you're actually going to need to use 2 or even more. The 4 types of joins are inner, left, right, and full. An inner join, often just called a join, returns records that have matching values in both tables. It's the most common type of join and the one you're most likely to see. If you look at this picture, you can see that of the 2 tables, only the inner portion where they overlap is returned. A left outer join returns all records from the left table and the matched records from the right table. So if you look at this image, you can see that it will return the entire left table, but only the portion of the right table that matches the criteria. A right outer join returns all records from the right table and only the matched records from the left. As you can see here, it loads the whole right table but only the matching records from the left. And a full outer join returns all records from both tables when there is a match in either the left or right. So it returns everything where either side has the value you're looking for. So let's get started on those queries. As you can see, I've created a few tables here. But for now, we're only going to be using the name and purchase tables. I've moved to Workbench because it allows us to see our results without clicking around quite as much. Our name table is just what you saw before. And the purchase table has some product names along with a name ID, which relates to the name.id, and the DOP, or date of purchase. So if we wanted to add the name to this list of results, we can simply say select star from purchase, join name, which is the other table we need, on, and this is where we specify how they're connected, name.id. Now, using the dot syntax simply helps you connect the name, the column, and the table, because ID exists in both tables. If we don't specify this, it won't know which ID we're comparing to. So name.id equals name_ID. And if I execute this, you can see that it gives us our results. Notice that even though there's 15 names and even more purchases, we've only gotten the results where the name ID equals the name.id. That's what makes this an inner join. To make this a left join, we use the same syntax, but we change join to left join. When we execute this, you can see we've now added the row for peas. That's because there was a purchase for peas, but no name ID was recorded. So now we have all of the products, but we have null for the name because we couldn't match that record. To make this a right one, we change left to right, and we execute it this time. We get all of the names, but it only has this many products to match. That's because there were no purchases made by these people. So everything else is null. Null just means empty. Now, if we change right to full, we're going to see that it actually gives us the same result as an inner join. That's because it's defaulting to an inner join because MySQL doesn't support the syntax for full joins. You have to achieve a full join by combining a right and left join. However, that requires a few things we haven't covered yet, so we'll have to push it off until later. That's it for this video. In the next one, we'll talk about doing more than one join, as well as the having clause. Picking up where we left off, we'll now discuss how to use more than one table. Now, according to the principles of table design we talked about, you'll remember that we really don't want to be storing the same data more than once. So I've changed our tables up a bit. Name is still the same. However, instead of using purchase like we did before, we're going to look at product, which now has the name of the product as well as a new column for distributor. And we have this other table called purchases that actually contains our date of purchase along with the IDs for the other two tables. So now we're going to need more than one join to connect them. If we start with the basic join we had before, with select star from purchases, join name on name.id equals name underscore ID, then we simply do another join on product with product.id equal to product underscore ID. And if we execute this, we'll see that it actually combines all three tables. It has the name as well as the product and the distributor. However, there's a couple of things that aren't ideal here. First, you can see that the column for your product name is just called name. This could easily be confused with a person's name. Also, when typing these, we're having to use our table names, and that can get long after a while. So we're going to solve both these issues by using something called aliases. To do that, we simply assign another value to the word that we're using. For example, purchases we can shorten to P. Name can be shortened to N. And product could be shortened to Pro, since we already have a P. And then instead of having name, we can just have N. Instead of having product, we can have Pro. And when we run it this time, we get the same result. Also, when we're doing our selects, instead of selecting all of these different IDs and a name that doesn't fit with our data, we can simply select what we want. So we can say name underscore ID product underscore ID DOP first name last name. Oops, that isn't capital. And then instead of using, we'll still select name, but instead of calling it name, we're going to say as product name underscore name. And we don't care about distributor right now either. So now when I execute, we're going to get a much cleaner list. Instead of name, it now says product name, so I can keep it clear. And I didn't have to retype the table names every time I was getting specific. In fact, if I wanted to add the IDs, I could even say p.id, n.id, and pro.id. and then I can add those IDs back in the select. And I could give them some names if I needed to keep them uniquely identifiable. So the aliases work both ways. But for now, we'll go back to our original information. From here, we're going to talk about the halving clause. The halving clause allows us to further filter our data now that we have it looking the way we want. To use the halving clause, we'll go to the next line and simply type halving. And let's say we only want them after a certain date. So we'll say DOP greater than, and we'll put it in quotes because it's not an integer, and we'll hit execute. And now we'll see that we only have the results that are further filtered by having a date later than the one we selected. Now this looks a lot like the where clause, and in fact you can even use them together, where last name like O and now we only have the ones that are after a later date and have an O in their last name. However, there is a few differences. The where is going to happen earlier on in the process than the halving, and there's some things that can come in between, and we'll talk about those in a later video. Well, that's it for joins. In the next video, we will cover some of the things that you can do with the query results after you get them. Brought to you by CreativeOnlineSchool.com. Welcome. In this video, we're going to be talking about the different ways to manipulate the data after you've retrieved it. Specifically, how to order your results, performing arithmetic on them, some string manipulations, and using the results you get as further query restrictions. So let's get in there. If we look at our purchases table, I've added a column for amounts, but other than that, it's the same. And currently we're looking at these results based on the order of the ID. That's the default because we're just selecting star, we're not giving it any further instructions. But what if we wanted to order it by, say, the date of purchase? Well, to do that, we would go to the end and say order by DOP. Now by default, it's going to order it in ascending order, or ASC. But as you can see, that orders it from oldest to newest. However, what if we wanted it the other way? Well, to do that, we would do DESC, or descending order. And that gives it to us from newest to oldest. It can do this because we've correctly labeled these as dates, so it knows how to order them. We're also not limited to only one order. As you can see, there's two orders on 910 and two orders on 810, and their product IDs are 13 and 94. Those aren't in any particular order. Well, what if we wanted them further ordered by product ID? We could simply add a comma and then do product ID descending. And now, not only are they ordered by date, which is first, but they're ordered by product ID in descending order. You can have as many of these as you wish. Now that we know how to order them, let's move on to a little bit of math. Let's say we wanted to do some calculations on these. Now I'll just be using mostly random numbers here for example, but you'll see what I'm talking about. So we're going to add amount to this result, but we're also then going to add 1 to it. So if I run this, we now have a new column, and it's calling itself amount plus 1 for now. We could name it with the as we saw in last video. But we now have this, which is amount plus 1. We can also subtract with a minus to have 1 less. We could multiply by 2. Multiplying in SQL is done with the star. That's going to give us a multiplied amount. Or we could divide. Dividing is done with a slash. And you can see we can even get results that have decimal places.
That brings up another important point. What if you get a result that's not quite what's in the format you want? This one has decimals. Well, we can fix that. If we want to round down, we use the word floor, and then we encapsulate it. By doing this, it rounds everything down. And if we wanted to go up, we could use seal, and it rounds it up. So that shows us how to do numbers, but what if we wanted to deal with strings? Well, let's go over to our name table. We have the names first and last, just as we wanted it, but what if we wanted instead to have the names together as full name, or what if we wanted the last name to be first? Well, instead of selecting star, we can select concat, short for concatenation. We open this up and we'll type last name, because that's what we want first, comma, we'll put an empty space here so that there's a space in between, and we'll enter another comma, and then we'll do first name, and we close it. So now when we run this, we're getting Donovan James as one field. Well, that's great for combining things, but what if you only wanted part of the name? Let's say we only wanted the first letter of the first name. Well, we can do that with a substring. In here, we can put substring, or substr. We'll open it up. We'll use the same name, but now we'll add a comma, and we have to select the positions that we want. Because we want the first letter, we're going to put 1, comma 1. This is from position 1 to position 1. And then we'll add another close. And when we run this, you'll see that we now have Donovan J, Patterson A. And if we wanted to go to 2, we would just change this to 2, or 3 in this case. And now we have the first 3 letters of the last name. That's how to manipulate characters. We'll continue on with how to use these things we're making to help further restrict our results in the next video. Let's pick up where we left off. We're going to talk about using some of those custom things we were making to further restrict our searches. Let's start with something simple. Name underscore ID plus product underscore ID. And we'll go ahead and also select star so that we can see the data. And we'll name this total just so that we can refer to it a little bit more easily. When we run this, we see our data, but we also see a total, which is product ID plus name ID. But what happens if we want to see the totals and only the ones greater than 10? Well, let's try it with a where clause. Where total greater than 10. It didn't work. That's because the where is looking for the information before it's created, because we're creating it as part of the select. But we have a solution for that. Remember how we discussed there was a timing difference between where and having? Well, if we use having, that takes place after the select, and so now we get the results we expect. Results of only those greater than 10. Now, as you can see, there are different product IDs, and there's different instances of, say, product ID 7. So what if we wanted to know the total amount of all of product 7's entries? Well, we can do that with a command called sum. Go over here and type sum amount. We'll leave it named total. And we'll have to set this equal to product ID equal 7. Otherwise, we'll get a total of everything in amount. So we'll execute this. Oh no, it didn't work again. Well, that's because having doesn't have access to the information that's not created from the data. So this one needs to be aware. The basic policy is that if it's in the data already, use aware. If it's something you're creating as part of the query, use have it. Now when we execute it, you'll see that the total for all of those amounts is 13. Now let's say instead of sum, you wanted to find the average of the numbers. You can simply change sum to average, or AVG. When we run this, you'll see the average of those numbers is 3.2500. We could floor it or seal it if we wanted to round it off, but we've already seen that. Next, let's move on to something a little different. What if we had data that we knew was supposed to be entered in a particular length, but may have been entered inaccurately? How would we find the correct ones? Well, we can do that with the length command. Let's say select length, first name, as total for naming purposes, and we'll also select star so that we can see exactly what we're lengthening. And remember, because we're creating this in the query, this is going to be a having command, having total equal to 5. If we run this, then we only get the results where there are exactly 5 characters in the first name field. This is very handy if you need to validate data of a particular length. That covers most of the basic things. In the next video, we will cover how to use these data manipulations more efficiently and how to get multiple results with grouping. This has been brought to you by CreativeOnlineSchool.com. Welcome. In this video, we're going to talk about grouping. Specifically, grouping as it relates to data, how to use grouping to get a single result, how to use grouping to get multiple results, how to use grouping in combination with other query actions, like the math or string manipulations we've already covered. So, grouping as it relates to data. Grouping allows us to consolidate multiple rows of a result based on a common data value. That means if our original query produced 5 rows, but they're all for the same person, we can consolidate it down to 1 row. And that allows for the production of a result set that contains only the information that we care about. Well, let's see it in action. We're back in Workbench, and we've already got loaded up a query you've already seen. It's joining the name, product, and purchases tables, and in this case, we're doing it where name ID equals 1. That's the name for James Donovan, so that we can see all of the purchases that he's made. And he's made 3. But what if we only wanted to produce one result set? Maybe we're looking at a result that's going to be fed to a program that's going to insert his name into an email. Well, we don't want to get 3 results back because he only has 1 name. Well, to resolve this, we're going to do group by. And we're going to group by, in this case, first name. When we run this, notice that we only get 1 record. And if all you need is a consolidated report and based on first name, you're fine. But what if we wanted to go a step further? What if we wanted to see what his most recent purchase date was so that we can include that? Well, normally you do that by ordering. And if you order by DOP, descending, you would think that would give you the most recent date. However, it doesn't. That's because the order by happens before the group, and the group rearranges everything. So if we want the most recent date of purchase, we're going to have to do that in the select. We'll get rid of the order by for now. Here, we can select the max DOP, and we'll go ahead and name it max DOP. And when we run this, we've now got a new row. It's showing us the most recent of the dates for James. Well, let's take it even one more step further. What if we wanted to use some math on these functions? What if instead of just some random amount in the group, we wanted to know the total amount of all of his purchases? Well, we can do that too. In the select, we just add sum amount. Because the group by is in effect, it knows what value set you're looking at, and so it will automatically sum them. And so we know the total is 18.
He's bought 18 products, and his most recent purchase is on this date. You can see how this kind of stuff becomes more and more useful the more you add. We'll stop there for now and continue on with the rest in the next video. Picking up where we left off, we have a max data purchase and the total amount of his purchases for James Donovan. So what if we're not just looking about James? What if we want to use everyone and find out their maxed data purchase and how many products they've purchased? Well, if we remove our where so that we're no longer caring specifically about him, we'll get that list. It's a list of one name and that name's max data purchase and how many items they've bought. However, we've run into an issue because we no longer have the ID requirement, and there were people with multiple first names that were the same in our database. That's why these numbers are so high. So instead of grouping by first name, we need to group by name.id. Because that's a unique field, we'll know that we'll only have each person once, even if that person has the same name. When we run this, that looks better. Now we have the totals for every individual person that's in our database, even if they have the same name. And we could further refine it with our having clause. We could also say having a max DOP. We did rename that accidentally up here, but it's fine. Greater than 10. And now we've even further refined it so that we only have the most high purchased people in our list. But what if we wanted to add some more information? What if instead of looking for the highest people, we wanted to see the total that each person bought of each product? So let's get rid of that having for a moment, and we'll add another group by. We'll do that by simply adding a comma and now saying name, because name is the field that we have called the name of the product. Now when we run this, we'll see that we not only have the max data purchase for James Donovan, but we have two of them. That's because this is the max date when he bought flour, and this is the max date when he bought butter. And he's actually bought butter twice. That's why his max of butter is 15, but his amount is only 7, because one of the times he bought 7 and one of the times he bought 8. So this breaks it out even further. Now we have a list of the total of each product that every person has purchased, as well as the most recent time they've purchased that product. That's starting to sound like some real business data, isn't it? Now, one of the things that often comes up is if we're selecting their name and there may be other personal information like their address or phone number, how do we make sure that we get the most recent record? Since we're currently selecting what amounts to a random one of these in the group, how do we ensure that we get the most recent and up-to-date information? Well, we're going to have to add some more content. It's called subqueries. And subqueries are going to be what we cover in the next video, as well as the uses for the null value. This has been brought to you by CreativeOnlineSchool.com. Welcome. In this video, we're going to go over subqueries, specifically what they are, the benefits of using them. We're going to go over some examples of basic subqueries and their use, and we're going to go over using subqueries to pull the most recent records. Remember that thing we couldn't do in our joins? We're going to go over that here. Well, what is a subquery? A subquery, also sometimes called a nested query, is a query that is run inside of another query in order to return a row or set of rows of data for use in the primary query. What that means is that you can select data and use it almost as a new table to join in with your original query. The benefits of subqueries are they allow us to dynamically obtain information that we need, and they also allow us to get information in a way that may not be available at the processing state we need. Because of our group by, our order by didn't work earlier.
but we can use subqueries to accomplish the same thing and get our recent dates. So let's go over an example of why we would need to use a subquery. You may remember this purchase table earlier. It contains our product info, but it doesn't have a product ID because it was never intended to connect to a product table. Well, if we wanted to use this info in our new queries, we wouldn't be able to connect them because of the lack of a key. However, with a subquery, we can find the appropriate product ID based on the product name. So let's do that. Here, instead of selecting from purchase, we're actually looking for the information that's in product. So we're going to select star from product, where product dot name, which was what we had the name of the product as, equals, and here's where we begin our subquery. Select product from purchase where ID equals 9. This will allow us to pull the information that we need based off the product name, because our product table, our purchase table, has the name of product, which is the same as the product.name. So when we run it, we see that P's, which exists in our purchase table, is actually product ID 5. And we could use that information to join it back in with the rest of the data. So that's fine if we know the ID or only want to pull one record, but what if we wanted to find all of the products that match our name that we have in the purchase table? Well, one way to do that with subqueries is to use right join. That will allow us to join all of the results of the query in with the main query. Let's show that now. We'll still be selecting star from product, but now it will be right joined, and we'll start our query. Select purchase.id as PID. It's good to give things like ID that are very vague different names when you're using subqueries so that you can reference them later and so you don't get confused. From purchase. And now we're actually going to do a join in the subquery. From purchase, join product on product equals name. Now we're going to give the result of this a name so that we can use it as a table. For now, we'll just call it A. And we'll say as A, just so that we have some more things here. Now this happens just like a table would. So we're still in the middle of our join. We now have to say what we're joining on. So we say on product.id equals PID. And that will allow us to join product to the results of this query. And if we run this, we can now get the product ID of every name that matches something in our purchase table. So we can now use it even though it doesn't have a key. We'll continue on with these in our next video.
Picking up where we left off, we're still talking about subqueries, and now we're going to use them to accomplish something we couldn't accomplish earlier. You may remember this query, where we used our double joins to produce a max data purchase and to sum the amounts by product type. But we weren't able to obtain the most recent data, so if we had phone number or email address, something we needed to keep up to date, this wouldn't be as useful as we needed it to be. Well, we're going to fix that with a subquery. In this case, instead of typing it, I'm going to paste it in just to save us some time, and then I'll explain it. We're going to take that same query, and we're simply throwing in this inner join right here. Now, an inner join is the same thing as a join. I'm just labeling it so that it can be visibly different. And within that join, we have this select statement. We're now selecting the max date of purchase, and we're calling it last date. We're also selecting the name ID and the sum of the amounts of the totals. We're doing that from purchases, and then we're going to group by name and product ID. It looks a lot like what we were doing on the outside, but now we're doing it on the inside, and we're calling it submax, the subquery max values. Because we're doing it within the subquery now, we no longer need to select these in our external query. And we're going to join the results that we get from this query on purchase data purchase equals submax dot latest date. So what that means is we're pulling out the data purchase just like we were before, but now we're only selecting from the table where that data purchase equals the max data purchase. That's giving us our most recent record. So when I run this, you can see that not only do we have our totals, and we have latest date here so we can use a comparison, but our latest date is also the date we're selecting with our other data. And you can see the product IDs and amounts have changed a little bit. That's because it's now showing the most recent record. This is a very common thing that you're going to need to do in your data, because usually the most recent record is the one that's going to be the most important. Let's pop back over and talk about something we've seen a few times but never really went in depth on, and that's null values. Null is a representation of an empty piece of data. It means there's nothing there. However, because there's nothing there, null is not actually a value, and so it cannot be compared with a value operator such as equals. If you try to check if a column equals null, you're not going to get any results. However, because of this, null values have their own operators, and that is null or is not null. Let's see this really quick. We're back in our purchase table because you may remember we had a name ID that was null. Somehow this got entered for a purchase, but we don't know who it was that purchased it. And it's the perfect example for us. If we were looking for all the information in our data that didn't have a value, we might try to say where name ID equals null, because that's what we see represented in the table. But if we try to run this, we're not going to get anything out of it. It just gives us a bunch of empty values. The same thing happens if you try to say equals an empty string or 0. We're not actually getting the table place where the value is null. And that's because we need to use the command isNull. If we do that, then we get our product, peas, and we can see that it's missing the information. This is useful when trying to find information that needs updating. You can also use isNotNull in case you wanted to obtain all the information where you had all the pieces of data. And in this case, we no longer include peas in our list. We have only those that have all of the data we entered. That's enough for this video. In the next and final lesson, we will cover transactions and sequences. This has been brought to you by CreativeOnlineSchool.com. Hello, and welcome to the last video in this lesson. In this video, we're going to cover sequences and transactions. A sequence is a set of integers, such as 1, 2, 3, that are generated in order on a specific demand. We already saw an example of sequences when we set our IDs to auto-increment in our tables. They go up by 1 automatically. That is in fact the most common type of sequence. A transaction is a set of queries that must all be completed before the action becomes permanent. One of the things that transactions is necessary for are things like auto-incrementing. The correct ID has to be determined, and then the insert has to happen. And we need to make sure that nothing happens in between, and so we can use a transaction. Transactions begin with start transaction command and end with commit if the transaction was successful, or roll back if not. It will undo everything that happened within the transaction. Let's see an example. Here we have our name table. Now, if we look at the actual table itself, we can see where we set the auto increment, and that's where we've been doing our sequence. But if we remove this and wanted to do it ourselves, I'm going to click apply. Now it's no longer going to auto increment. Instead, we're going to have to do it manually, and we'll do that with a transaction because we don't want to find out the correct ID to use and then have the ID change because some other insert happened between them. So we're going to go up here and start our transaction. Now, in a transaction, it's important that everything happens individually. So we're going to add a semicolon to the end, and that says run this and then do the next thing. Now we'll do our select. We'll select ID from name. And we don't need a where because we want the max ID. We'll just put max on this ID. Now we're going to have to do one other thing as well, because we need to use this ID in our next statement. We're going to have to assign it to a variable. We'll do that by saying at a colon equals, and that'll allow us to use at a later on in the sequence. So we'll put a semicolon on this one, and now we'll run our insert. Insert into name set ID equal to at a plus 1, because remember we want to auto increment. We already have one max value. Then we'll set first name equal to Oliver and last name equal to Tanel. And then we'll commit this transaction. So if I run this, and then we go back and look at our our name table, we've inserted Oliver Tanel, and we've auto incremented the ID by using our transaction. Now, if I were to go back and try to run this again, but instead of committing, I used rollback, you're going to see that it did not insert a new value. That's because the rollback canceled everything that happened before it. It didn't make it permanent. This isn't too common when having to do things interactively like we're doing. However, if you're doing a whole lot of transactions in code, you may need to check that each one is successful before determining whether you want to commit or roll back. And that completes our lesson on MySQL and queries. I hope you enjoyed it. This has been brought to you by CreativeOnlineSchool.com.
Welcome. In this video, we will cover Sublime Text and using it for your files, the format for creating a PHP file, what a variable is and how to use it, how to display information with PHP, and then we will use that to create our very own PHP web page. Sublime Text is a text editing program, and it'll help you with your code by taking different commands and symbols and making them color-coded so that they're easier to track. We'll use it for our video to help us see what's going on. If you would like a copy, you can download it at sublimetext.com. So here we are back in our lessons folder. I've created another file called index.php, and I'm going to open it. This is what it looks like inside Sublime Text with some color changes that I made. So to begin a PHP file, we have to identify where the code is going to be. Open question PHP. This indicates that we're making a PHP file, and this is recognized as code. And we'll end it by question close. All of our code will go in between these two things. So first, let's talk about variables a little bit. Variables are containers for bits of information that aren't defined until the file is run. So you can set them in the code, or you can pull them from somewhere else when the code runs. We're going to start with a basic one, and in PHP, all variables start with a $sign.
$, and we give the name. I'm going to just say var. And we'll set var equal to 4. And all statements in PHP end with a semicolon. So next, we'll do another variable, and we'll call it var2. And this one we'll set equal to a string. We'll open some quotes and put in some code. Hello from Creative Online School.com. And we'll close this one. Now, we have some variables in there defined, but when we run this file, it's not going to look like anything happened because we've not told it to display anything for us. We have to tell it to output some kind of information. We're going to do that with the echo command. We'll say echo var1, or just var, and we're going to use something called concatenation here. By applying a dot afterwards, it will connect us to the next thing. We'll make a quick empty string with just one space in it to separate our values, and we'll put dot var1 or var2, and we'll close that one. Now, when we close this file and save it, we can go over to our browser and see that instead of hello world, when we run it this time, we're going to get 4, hello from creativeonlineschool.com. This is the first variable, the space we added, and then our second variable. And you may notice we didn't have to put in an extension. That's because XAMPP prioritizes index.php over index.html. But in some cases, you may need to define that. So let's go back into our code for a moment. And this time, we're going to do something a little bit cooler. First, we'll take our variable and add a third one with our number, variable 3, and we'll assign it equal to 6. And instead of just having a basic string, we're going to say we have some HTML in here. Now I'm going to paste it in so that you don't have to watch me type it, but if I paste here, we've now got some HTML tags and a new body tag. Now, instead of just echoing var, we'll put in var plus $, var3. That allows us to do a little math so that you can actually see this accomplish something. And now that var2 is its own HTML, we no longer have to concatenate it. So we can have this as a statement, and we can echo just var2. So let's save it and watch it run. There you have it. We have our total of 10 and a new header of hello from creativeonlineschool.com. This is the basics of creating a web page with PHP. You create the HTML, you assign it to a variable, and then you output that variable to the web page. Thank you for following along with us while we made our web page. This and other lessons can be found at creativeonlineschool.com. Welcome. In this lesson, we'll go over how to use PHP to accomplish conditional logic, creating a form with PHP, getting data from that form with get and post, creating and using arrays, and using for each to process arrays, as well as things that are similar to arrays, like return database information. First, conditional logic. We're going to talk about 4 primary things: if else, and while. If checks if a particular condition is true. That is, it checks a particular variable and says if that variable is what I expect it to be, or meets the condition that I set, then I'll let this pass and execute my code. The most common operators are equals, non-equals, exactly equals, and then you have greater than and greater than or equal to. It also has the ability to check if something exists, so if it's there at all. Next is if-else. These are always paired with an if, and it creates a subsequent check on the condition if the if was not true. So it tries the if, and if the if fails, it proceeds to the if-else. Finally, we have else. It is also always paired with an if, and it comes after all the other if-elses. If all the checks fails, both the ifs and the if-elses if they exist, then it will execute the else. The while continues a contained process as long as a particular condition remains true. So once it's true, it gets in until it changes. And it uses the same operators that if uses. Here we have the project we made in our last video. So we're going to use it to learn about ifs. First we'll set another variable. We'll call it check, since we're going to be checking it. And we'll set it equal to 5. Next, we're going to go down and set an if around our echo. $check equals equals. Now we're using 2 because if we only use one equal, it'll assign a value to a variable. We're checking if a value is a variable, so we have to use 2 of them. And we'll set it to 4 just so that we can see it fail and know that it's working. Next, we'll open our brackets, and we'll put a closing bracket after the echo. That means the echo will only execute if this is true, and it's not. So, let's see if it removes our creativeonlineschool.com sentence. Yep, it sure did. Next, we can go and see it reappear if we set it equal to 5. This is our new lesson from creativeonlineschool.com. It's back. So, what if we want to do more than one check? Well, we can then use an else if. So you come down here and say else if check. We'll say greater than or equal to, just to make it a little different. And then we can say echo second result. Now, what do you think we're going to get? It's the same. That's because the else if only fires if the if fails. And this one didn't fail. It was true. It is equal to 5, so it never got to the else if. But what if we changed it from 5 to 6? When we launch it this time, we see the second result. That's how ifs and else ifs work. Next, we're going to say else and open it again, and this time we'll echo third creativeonlineschool.com. And if we can get all of these to be false, it should reduce that. So we're going to change check from 6 to 3. And now when we see it run, third creativeonlineschool.com. This works because it failed both the if and the else if. And if it fails everything in the list, it will process the else. This is a good way to catch all if you're not entirely sure what data you're going to be processed. If you don't know what the value is going to be, and it could be anything, then you need an else because you can't check for everything. We'll continue on in our next video. Continuing on, we're going to talk about the next conditional variable, and it's called while. What we're going to say is while check is less than 7, then we execute what's inside. So what we're going to do here is we'll echo the value of check along with concatenating a page break so that it goes into another line, makes it easier for us to see. And then we're going to say check plus plus. That's a shorthand way to just add 1 to a variable. Now when we run this, we're going to see 3, 4, 5, 6, and then it stops. That's because check was initially 3, and every time it hit the while, it said, I am less than 7, let me run this, and then add 1. And then I'll run it again, and add 1, and add 1, until it got up to 7, and at that point, it was no longer less than 7, so it stopped. It's a good way to repeat information a particular number of times, or until a particular thing becomes true. Continuing on, we'll now talk about forms. We're going to go back to this page we made earlier, which has our header for Hello Creative Online School. We have it here. It simply puts out a number and then our header. Well, we're going to add a form. I'll just paste it in here so you don't have to watch me type. And I'll go over the parts real quick. The form action is the location of our file. In this case, the file I've made is called index2.php. We're going straight to this so that we can use it as an example. And we've set the method equal to get. That's going to be important in a moment. There's 2 simple inputs here, one called name, and then a submit button. So when we go and view this, we'll now see that we have a simple input box along with a submit button. Now, if I were to enter something into the box, like my name, and click submit, it's going to show us the same page, but if you look at the URL, you're going to notice that there's now a question name equals Justin in the URL. That's because our method was get. It's going to assign the different things we put into the form to the URL. And if we go back to our code, we can do something about that. First, we have to check if the get exists. That way, we know whether we need to execute it or assign it to another value. We can do that by saying if is set, which checks if it exists, $_get, open brackets, the name of our field in quotes, because this is called name. This is going to pull name, because name is what's going to be in the URL. And then we'll say if it exists, then we'll set var equal to it. Var equals $_ get name. We'll use our else statement here to say else var equals 4. So if we have a get, it should be set to what we have, and if not, it'll assign it to 4. We'll save this and go back to the web page. Now for now, I'm going to remove this so that we can see it from the beginning. We've loaded our page. It says 4 and hello from creativeonlineschool.com. And when I put my name in this time, click submit, instead of 4, it's put out Justin. That's because it's pulled it from the URL where it says name. That's how to use gets in PHP, and you can submit your forms to them and have the information accessible in your code. We'll continue on with some more form information along with some other types of PHP functions in our next video. Okay, so we're still on the form we made with our get functions, and we have our name passed through the URL. But there's some extreme limitations to using get. First, all of your information is displayed for all the world to see. What if you have sensitive information? Or what if you're passing a huge amount of information? Maybe you have a lot of different fields or one big field. what if you just think it doesn't look very nice and you want to keep your site URLs looking clean? Well, we have another option for that, and it's called post. If we come back to our code, we can change the method to post, and it's handled much the same way as get. Basically, we'll just change the gets to posts. Now when we go back, we'll start again from the basic one. And we have 4, hello from creativeonlineschool.com. This time, when I put my name in and submit, I still get my name, but there's nothing in the URL. It stayed the same. This helps us keep everything looking clean and be a little bit more secure since it's not on display. Now, to learn a little bit more about the post and gets, this syntax where you see the brackets is because the post and get variables are arrays. Arrays are sets of information instead of individual values. And as such, they need a little bit more information to tell which part of the set that you're looking at. We're going to start making our own so that you can understand them a little better. So instead of setting var equal to 4, we're going to set var equal to array. And if we open it up, we can just put different things in the array. We'll say different names. Tony, Steve, Tony, Steve, Jeff, Franklin, and this is our list of names. Notice they're just strings and they're separated by commas. Now, what happens if we try to echo this? I'm going to go back to our web page and we'll take this and refresh it. Oh no, we get a warning. Array to string conversion, and it doesn't work. That's because arrays can't be echoed directly. You have to echo what's in them instead of the whole thing. Now, we can display an array with a different command. It's called print_r. And then we open some brackets for it. And now if we go back to our page, you'll see all the different things in the array. Tony, Steve, Jeff, and Franklin. However, this is printing the array in its complete form. You see there's numbers next to them. These numbers are the indexes to these names. Tony is at position 0, Steve is at position 1, and so on. For whatever reason, they decided to make it start with 0 instead of 1. That can be confusing for folks, but it's just something you'll have to remember. But what this means is, because we have an index, if we did want to echo an individual value that looked neater, we can say echo var, and now we open those brackets and say 0, and now when we load the page, we'll just see Tony. That's how you access an individual value in an array, and that's what was going on in our post. We were pointing to name because its index was name. We'll continue some more about arrays in the next video. Now that we know how to create an array and we know how to view what's in it, we can start manipulating it and see what we can do. I'm going to change this back to print_r so that we can see the whole array and we can see what effects are going on inside, even if it is a little less clean. And now before it's spit out, I'm going to see it about adding something. So we have our array already with Tony, Steve, Jeff, and Franklin, but I'm going to say array_push and open up, and we're going to put in the name of our array, $var, and then the value we need. We'll say Billy. If I do that, then let's watch what happens. Now we have our array, and on the end of it is Billy. We've pushed Billy onto the array. Now, I can also do another command called array pop. And we just put in the variable name for this one. So, there you go. And now, when we see it run, you're going to see that Billy's gone. Pop removes whatever the last thing in the array was. So we can add someone and then we can remove them. It's also possible to do updates. To do that, we're going to use the syntax we saw earlier. We're going to say $, var at 2 equals Arnold. We'll give him a capital since everyone else has one. Now when we save this and we run it, you can see that Arnold is now number 2. We've updated someone in the list by declaring which one we wanted to update and what value to set it to. Now all this works if we only want to do one record at a time and if we're just spitting out one record at a time. But how do we do things for the entire array? If we wanted to know everyone that's in it without printing R, what if we wanted to echo every value, but we didn't even know how long it was, so we didn't know what numbers to put in? Well, that's what we use a command called forEach for. Now, what we're going to do here is say forEach $, open, $, var, as, we're going to call it index, because that's what it's going to be for us. Then we'll do what's inside. And what we're going to do specifically is we're going to echo index, and then we're going to echo a break tag. Now let's see what happens when we run this. We have our print_r, but we also have Tony, Steve, Arnold, and Franklin all input by themselves. It looks a lot neater. We can do this because of the forEach. It goes through each item and assigns whatever's at that index to the value that we set here. And then we can echo that as an individual value. We'll move on with these in our next video and learn a little bit more about arrays as well as how to use them when they come from forms. So now we've covered using basic arrays. You can push them, pop them, or modify them to add, remove, or change something that's in an array, and we know how to create them. But one of the most powerful things about arrays is that they're not only in one dimension. You can not only have an array of values, but you can have an array of arrays, or even an array of an array of an array. We're going to stick with 2 dimensions for right now, though, because it gets a little complicated. So first, I'm going to change our values here so that instead of a 1-dimensional array, we're going to have a 2-dimensional array. We simply say var equals array like before, and this time, instead of comma-separated values, we have comma-separated arrays. And then these arrays are just like the old statements. Here I have a list of some car names and then some random numbers. Now, what's going to be interesting here is now that this is an array of arrays, our forEach can't process it anymore because now index is going to be another array. So what we're going to have to do to resolve that is stack our forEaches. So we'll go inside and we'll say forEach index as $value, then we'll create some input. And this time what we're going to do is we'll echo value in here, but we're going to leave the break tag out here. And what this is going to do is make it so that we're going to echo all of the values of the inside of the array, but we're not going to go to a new line until we change arrays. This allows you to start having some flexibility with your output. And let's line these up a little bit, just so that they're a little clearer where they're going. It's always a good policy in your code to keep your opens and closes on the same line so that you know where your values belong in each statement. Because if you have multi-dimensional arrays or anything else, a for each of a for each of a for each can get really confusing. And we'll also put a space at the end of our value so that we can tell them apart. The numbers will be separated a little bit. And we're going to have to comment these out because we don't want these to process. If you put 2 slashes in front of something, then when the file runs, it'll basically ignore these. It's a good way to comment stuff if you want to describe the code that's below, or in this case, make some code not run. Push and pop doesn't work with multi-dimensional arrays, so we're going to comment it out. We're also going to comment out print_r just to make our screen a little clearer. And now here's the result. Now we see Volvo 2218, a new line, BMW 1513, and we can print out different values. We now have all of this stored in one multi-dimensional array, but we're processing it out so that it's formatted how we want it to. Now, arrays are important for more than just formatting data. In fact, you're going to need them for a lot of our forms. Let's see why. If we come back in here to the form we made, we're going to add a new input. This one's going to be a multi-select. In this case, the select's name is lessons. And notice these brackets right here. This indicates that we're going to pass more than one value back. It's going to pass back an array full of whatever options we select. So we're going to get an array back, and we're only going to get a one-dimensional array. So we're going to change our for each here to be back to a single-dimensional one. We're going to copy index over value. And then let's go ahead and change our else up here so that it's one-dimensional too. Copy this. There we go. And now we'll save the post name to lessons. We've saved our file. Let's watch it run. The first time, we have everyone's name because we don't have any post data. But our actual form is down here, and it says, hello from creativeonlineschool.com, and asks for your name, and what lessons do you want to learn? And we have 4 options. Let's say that we wanted to learn about SQL and Oracle. Let's click Submit. Now it's printed out MySQL and Oracle, the 2 values that we selected. It did this because we submitted it as an array, and that array allowed us to print out the values. Many kinds of form elements will be passed as arrays, and you're going to need to understand a good use of them if you're going to make web pages. Hopefully these will give you good examples. That concludes our lessons on PHP. Thank you for watching, and this and other lessons can be found at creativeonlineschool.com.
Welcome. In this lesson, we're going to go over creating a database connection with PHP, how to then run queries through that connection, process the query results you get back with PHP, and then we're going to use those results to build our web pages. Let's get started. Okay, so the first thing you need when connecting PHP to a database is a database to connect to. So I've got one here on the right. It's called person, and within it there's some tables. For now we're only going to care about name. Name has 2 columns of importance, first name and last name. And the last record is currently Oliver Tunnell. The second thing you need is a user that we're going to use to connect to the database. It has to have the proper permission so that we can access it
from our PHP file. Different interfaces are going to get you to your users in different ways, but we can see mine here. We're going to be using this one here. I've called the user demo, and it's from localhost. You can see that its privileges are set so that on the database person, it has all the privileges it needs. Although primarily, we're only going to care about select, insert, update, and delete. So let's go back to our name table, and now let's do something with PHP. So PHP is going to connect with something called MySQL. So we're going to say $MySQL equals new MySQL. Then we're going to open our thing and say where we're coming from. In this case, localhost. And we have our username, so demo, our password, which is demo pass. It's great to have passwords on your users because you don't want someone to be able to use it to access something that you don't want them to. And then we select our database name, and ours is called person. That'll create our connection to the database. And then, in order for us to connect to the table and actually run our queries, we're going to use $MySQL arrow query, and then we open it up and we put our query in here. To start with, we're going to do an insert. Insert into name, set first name equal to Tommy, last name equal to Thompson. Now let's see what happens when we run this. We'll go over to our page and we'll run it. And now if we go back to our database and we refresh it, we can see that we now have Tommy Thompson in our database. We've successfully connected to a database and made a query that inserted into it. Now we'll do not just a command, but a select so that we actually get our results back into our PHP code. First we'll set a variable, we'll call it result, and we'll set that equal to the same thing we have up here. So I'll just copy and paste it. And we'll change our select into, or an insert into a select. We'll say select first name from name. We don't need a where because we're selecting them all. Next, you have to go through your results. The result you get back isn't actually usable in PHP because it's a different type of object. So we have to go through and convert it, and in our case we'll convert it into an array. So what we're going to do is, while row equals result arrow fetch array. Fetch array is something already in PHP to help us get our query results. So we can do in here, we can treat it just like an array once it's been assigned to row. So if I were to echo $row, and it is an array, so we'll have to do at position 0 since we've only got one column. Then let's watch what happens here. There we have all of our names. James, Al, Steve, Amy. We didn't do any formatting, and we'll fix that in a minute, but you can see us getting some results back. We'll pick up with improving this and moving on to some more complex stuff in our next video. So picking up where we left off, we're going to talk about how to make this a little bit neater, as well as some options that'll make our lives easier as we continue to run queries. So the first thing I'm going to go over is the fact that unlike most arrays, these particular arrays, because they came from queries, have more than one index. you see that I echoed row at 0, but I can also echo row at first name. Although I'll need to encapsulate that. And if we were to put a space at the end of this, we can see it a little bit more clearly in our other side. Let's run it now and see what it says. You see, we still get the results, even though we have first name instead of 0. That's because first name is also an index for the value. Now, it's easy to do this when you only have a few results, but there's two cases that you're really looking for when you're running queries. You're either going to be getting a result set like this one, or you're only going to be getting back a single value. Maybe you want to pull one ID, or maybe you're looking for just the person's name when you load the form. And in order to do that and to make things more simple, we're going to turn these into functions. So first, I'll turn this into a function, simply saying function and dbQuery. And we'll pass in a variable, which is going to be our result. And we'll open this here. And all of this is going to exist inside our function. And instead of result coming from the variable we set up here, result's going to be what we passed into our function. So we can accomplish the same thing we had earlier simply by saying dbQuery and passing result. It still works. So now we have a function that gives us our results back. Although for right now, it's only giving us first name. So you may be thinking, what if we had more than one result? What if we had first and last name? Or what if we didn't know exactly how many results we were going to get into it? Also, we're not formatting this very well. It's just echoing our results out directly. What if we were building HTML? Well, I've already got a little program made, and I'm going to show it to you. We'll walk through it to help you understand how to better utilize some of these functions. Here it is. Now it still starts with the MySQL and it makes our connection. However, now our query is much more complex. It's actually getting several values from several different tables. It's going to join our name, purchases, and product tables so that we can get information out of each of them. And because we don't know exactly how many rows we're going to get, we're going to have to do a count of our result. We're going to do that by using MySQL arrow field count. This will give you back the total number of rows that are returned so that we can loop through them later. And I've incorporated some HTML here. It begins by creating a basic HTML document, and we have an empty head and a body, and we're actually going to be able to format our data straight into a table so that it looks nice and neat when we run it. We've given them some titles because we're selecting first name, last name, product name as product name, and distributor as well as date of purchase. So we've got headers here for those values. Next we come down here, and this is what is going to allow us to process our results. Just like we had before, it's row equals result fetch array, and we're creating our tags. However, inside of this we have a for loop. We're going to loop through each time incrementing by 1. And as long as the result of that increment is less than the total number of rows, it's going to continue running through the for loop and creating RTDs. This will make it so that we change rows every time we get a new row from the database, but we print our columns from left to right. And then we can close our HTML down here. Now let's see what happens when this is run. Now that looks a lot more like databases. We've got all of our names coming out in rows and columns, and we've done it with pretty much exactly the same thing we've been using the entire time. Just while loops, for loops, and our MySQL. That's it for this lesson. Thank you for watching, and this and other lessons can be found at creativeonlineschool.com.
Hello, and welcome to Python with MySQL Database. I'm your instructor, David Baker. This course is brought to you by creativeonlineschool.com. Before we get started with the actual instructions, I'd like to introduce myself. Again, my name is David Baker. I have 8 years of Python programming as well as in other languages. I have 3 years of programming with MySQL and specifically Python and other databases in multiple languages. If you are interested in any other courses or interested in more about Python, I would highly recommend Creative Online School as a resource and to use their tutorials. So going forward in this course, what will you be learning? Well, I'm going to start off with a basic introduction to Python so that we're all on the same understanding and same knowledge base. And then I'm going to get into what a database is and why we're going to be using it. Then we're going to start looking at the actual coding and how to connect a MySQL database to a server and how to create this database, and also how to create tables and store information inside of these tables. Next, we're going to move on to how to visualize this information in a web page for those of you that are looking to display your product or anything online. And then finally, we're going to look at how to optimize our database creation with classes. If you don't know what a class is right now, no worries, I'll explain that in a future video. So let's get started with a basic Python introduction. The first thing that you will need to know are variables and what they are. So what a variable is basically just a representation of something else. This can be thought of as in math when you have x or y equal to anything. So let's just go ahead and go into a Python terminal so I can give an example. So if you have any variable, say we have the variable v, and we try to see what v is holding, it gives us an error in Python because when we first start it, there is nothing that v is set to. However, if we put quotation marks around v, then Python knows that we're just trying to show v as a letter and not necessarily reference it as a variable. In order to set up v as a variable, what we will do is set it equal to anything. So I'm going to set it equal to the string hello creative online school. Oh, excuse me. Forgot the O. So hello creative online school. And once I press enter, v is now mapped to the string hello creative online school. So variables are also used in comparisons, which we will look at in the next video. However, this is just a basic understanding for you so that you know what a variable is and also how to use it. I hope that this video has been helpful for you, and in the next video what we're going to be looking at are data types and which data types to use when and how their interconnectability. Thank you for watching. My name is David Baker, and again, this video is brought to you by Creative Online School. Hello, and welcome to Python with MySQL Database. I'm your instructor, David Baker, and this course is brought to you by creativeonlineschool.com. In the previous video, we learned about what variables are, and I gave a brief introduction to myself. Going forward in this video, we're going to be learning about what data types are and why we need to use them and why there are so many different ones. So let's go ahead and get into a Python terminal. And the first data type you would need to know about are what booleans are. So a boolean is just true or false. And in Python, true and false are capitalized to make them booleans, otherwise they're considered just strings or they can be set to variables. But true and false are just a logical comparison or a logical return of a comparison. So if I'm doing 1 equal to 1, so I'm asking is 1 equal to 1, it will say true. If I ask is 1 equal to 2, then the boolean that is returned is false. Again, these are just boolean data types. Going forward, next we have strings. Strings are anything enclosed in quotation marks. So again, we can have hello creative online school, and this would be considered a string, and once we print it out, we get a string back. These strings can be any length, and they can also contain numbers in them. So hello creative online school 521, and still considered a string. The next data type are numbers, but however in Python there are two types of numbers. There are integers and floats. So integers are fairly self-explanatory. Integers are anything such as 1, 2, 3, 4, so on and so forth. They're just numbers that don't have any decimal place, or as most people know them, whole numbers. Floats, on the other hand, are numbers that have decimal places. So anything like 1.2 or let's say 3.0, these are all floats. The important difference between these are in Python, when you're doing math, specifically division, you get different data types returned based on the method that you use. So if I do 1 divided by 2, I will get a float returned because I'm using this single slash or single forward slash. However, if I use a double forward slash, I will get a boolean, not a boolean, but an integer returned, because this double slash means that I want to round it to the nearest integer, or I need an integer returned. This can be important for any specific operation that you're doing. If you cannot be using floats, you need to know that you need to use the double slashes. The next data type that we have are lists. So a list is anything that is enclosed in braces. So I'm just going to make a list of 1, 2, 3, 4, 5, and lists contain several elements that are comma separated within the list. And so we just hit enter, and then we can print out the list and see what's inside of it. The important thing about lists is that we can index into it. So we can see one element out of the entire list. So if I do L of 0, so I'm taking the 0th element, which in Python is the first one because Python starts indexing, counting at 0. So it goes 0, 1, 2, 3, 4, and 5. So I can access any point in this list by accessing its index. However, if I go to index 5, it is out of range because I do not have a fifth element according to Python, because 5 or the fifth number would actually be a 6th element. Next we have sets, which are extremely similar to lists in the way that they can store multiple or a large amount of information and multiple separate pieces of information. However, with sets, they are unordered. So a set you cannot index into, which is very important because sets contain less metadata, and that means that they take up less space on your computer and they take less time to actually find information in. So this is just like a difference of when you would use lists and sets if you're trying to save some space. And the final one that we will be talking about today are dictionaries. So a dictionary is a set of key value pairs, and what I mean by that is I will show you. So we have a key, and then we have the value separated by a colon. And I'll go ahead and put another element in here, which will just be separated by a comma. And I'll just put hello, and then I'll put as the value creative online school. And then we just hit enter. It stores this dictionary, and dictionaries are also unordered in their individual elements. However, their key value pairs are still mapped to each other. So I can access each individual value within the dictionary by typing in their key. So to access the first value, or the value of key, in this case I would type in key, I would get value. So this would be this first pair of information. To get the second pair of information, I would type in the key hello, and then I will get the value of creative online school. I hope that this video has been helpful for you with a just brief introduction to what data types are and the different data types within Python. In the next video, we will actually be learning about what a database is and why to use them. Hello, and welcome to Python with MySQL Database. I'm your instructor, David Baker, and this video is brought to you by CreativeOnlineSchool.com. In the previous video, we learned about what a database is and specifically how a MySQL database is laid out. Today, what we're going to be learning about is actually creating this database in Python, which is going to be my favorite part because we actually get to start coding. So let's go ahead and create a file, we're going to create a file which I have already gone ahead and done, and I just named it database.py. The top line from here is just if you're in Linux to be able to run a Python script in terminal. And the first thing that we want to do is we need to import the module. So we need to import what is PyMySQL. So this is the 3.5 version of MySQL in Python. If you have a different version of Python, you're going to need to import a different module. And let's go ahead and get started. So first thing that we need to do is actually connect to the server that's going to be hosting it. So we're going to connect by using pymysql.connect, and we need to give some parameters. The first parameter being the local host of where the the host name of the server, which for me is localhost since it's on my own computer. Next will be the user that you want to log in as, which for me is root. And finally, the password of this user, and mine is simply mine. Next thing that we need to do is set up a cursor so that we can actually interact with the server. So it's just going to be server.cursor. And finally, we're going to actually create some SQL code. So what I'm going to do is I'm just going to create a database. So just create database, if not exists, Creative Online School. And then we end our SQL code. And finally, to send our SQL code to the actual server, what we're going to do is cursor.execute and then SQL. So this will actually create the database within the server, and the next thing that we need to do is start creating tables. So I'm going to go ahead and use Creative Online School. So this is just telling the server that I want to start manipulating the database Creative Online School. And then just go ahead and execute this code on the server. And this is where we're going to start to actually create the tables. So we're going to do create table if not exists, owners, and then ID is going to be an integer and not null, and go ahead and auto increment it because we want each individual ID to be, or each ID to be individual. And then we go to the next one, and we're going to do name. It's going to be a varchar, and let's select 30. And we want to have this information, so make it not null. Next will be gender, varchar of 7. This is where all of the data types come into play. It is not necessarily in actual Python, but in other languages, because you have to specify in a database what kind of data type you're going to be entering into each field so it knows what to expect. And then just set our primary key to ID. And go ahead and close this out, end our SQL code. And I'm using these triple single quotes so that I can enter my information on multiple lines. If you want to enter in all of your information on one line, you can do that with just a single quote. I was just showing you a way to do it. And then I've already got the next information copied down, so I'm just gonna go ahead and copy that over for the next table so that we save some time. And go ahead and copy. Okay, so then we just do cursor.execute SQL, and we can see we can tell if these tables were created inside of the database by actually using the command in SQL of show tables. So we'll just do show tables to make sure that we have actually created them, and cursor.execute. Another command that you will need to know is cursor.fetchAll, which will actually receive anything that the server just returned and return it to the actual Python script, so it doesn't automatically download it. So we just print out what cursor.fetchAll takes, and it should print out our tables. So now we want to just run this script, and there we go. We can see that we have created the table of owners and pets. I hope that this video has been helpful for you in learning how to create a database and also tables within Python. In the next video, we will actually be loading data into these tables and learning how to manipulate it. Again, my name is David Baker, and this video is brought to you by CreativeOnlineSchool.com. Hello, welcome to Python with MySQL Database. I'm your instructor, David Baker, and this video is brought to you by CreativeOnlineSchool.com. In the previous video, we learned about how to create and connect to a database in Python. And now going forward in this video, what we're going to be doing is actually loading some data into this database so that we are able to use its functionality. First thing that we need to make sure that we have is some actual data. So if you remember from when we were going over the concept of what a database is, we created some fake information which I have just put into text files here. These text files are just comma separated by the rows, so we have in our owners table, we have our name, and then gender and phone number. You might be asking where the ID field is. However, if you remember, the ID field was an auto-incrementing field, so we don't need to actually input it. It will automatically input that data, just the way that MySQL is set up. So now let's go ahead and get into our file. So I just created a file called loaddata.py, and what I've done in here is, for those of you that do not know, what this means is just basically when I run the file, I want everything that is underneath this if statement to happen. So the first thing I'm going to do is actually connect to my database, Creative Online School, and then I'm going to create a cursor and then call load owners and also load pets with that cursor. So what we're going to need to do is create these two functions. First thing that we need to do in load owners is actually open our data so that we can use it. So we're going to do owners.txt. We're just going to open it up as a regular file, and then for row line in owners data, and we want to split this data by the commas because it's a comma separated field. And then we just need to make the SQL query, insert into owners, name, we need to actually give it the columns that we're going to be entering, and phone, and then our values that we're going to be entering. And what I'm going to do here is I'm going to use a format strings method. I'll explain exactly how it works once I have it all laid out for you. And finally, we will close the parentheses and stop our SQL query. And then I just use .format, and I specify what I want to go in between those braces. So for me, I'm just going to index every item in the row, And what is important about a dot format string format is that these single quotes around the braces tell where dot format needs to insert. So that is extremely important. They need to be single quotes and not double quotes. And then we just do the cursor.execute SQL. And finally, we're just going to go ahead and on the outside, we're going to make sure that all of it is loaded in, and we just want to see it. So select star from owners and print cursor.fetch all. And I've gone ahead and created the second load pet so that y'all don't have to sit here and watch me actually go through it again. I just need to format it out. And the only thing that I've done different in this one is I've done the dot format method differently, where I index each element in the row inside of the brackets, and then I just use a star row in the dot format method. It's just two different variations. So then we go to after we run both of these functions, we do db.commit, which actually uploads all of our information, and then db.close. So let's go ahead and see if this works. /load data, and row is not defined. I must have misspelled it. Let's see. Yes, I did dot row line instead of equals row line. So let me just do that. And there we go. We have loaded all of our data. We just printed out the owners table, and here's all of our data. I hope that this video has been helpful for you. In the next video, what we're going to be actually looking at is how to display this data in a table format in HTML using Python. Again, my name is David Baker, and this video is brought to you by CreativeOnlineSchool.com. Hello, and welcome to Python with MySQL Database. I am your instructor, David Baker, and this course is brought to you by CreativeOnlineSchool.com. In the previous video, what we learned about is how to actually load data into our database through a Python script. Going forward in this video, we're going to be learning how to display this data that we get from the database and put it into an HTML table. This is helpful for anyone that is trying to display any product information or anything like that on the web page. So I've got this file here, and I just called it rendering.py, and don't be alarmed by how much code is already here. We've done most of it, and anything that we haven't, I'll explain right now. So this HTML head, all it's doing is adding into an HTML string the header information for HTML, since we're creating the actual HTML inside of a Python file. Same thing goes with the foot HTML, except for it's just doing stuff with the footer. And then this owner query is just going to select everything from owner, so we actually get all the information, and we're going to return it at the end. And then this SQL query right here is telling us to get all of the names of all of the columns in owners. And then we do the same thing for the pet, and then we also create the pet table. What we're going to be working on today is this owners table. And if we go down to the bottom, we can see that the startup information is, we just call it HTML head, and then we're going to do the owner query, and then we're going to do our owners table. If you need to, you can copy down all of the information by just pausing the video and copying down the code. And then right at the end here, we're going to write out the HTML to a file and then close it. So let's get started on creating this owners table in HTML. So in Python, what we're going to do is we're just going to start with creating a table. So table, and we're going to give it a border just so we can see easier of 1. And then we'll add a row for our column names. So and we'll keep track of how many column names there are with this I in column names. I'm going to add, and for HTML you just do header for table header and then we do our name of 0. The reason that we have to index into our name is because the information that we get returned from a SQL query is actually in a list of lists, so we have to index into the second list. And then don't forget to increment our I. And then we close this row so that we can start with our actual information that we want on the table. So we're going to input this information, owners list, and we're going to do HTML plus equals another row. So what this is going to do is it's going to add a row for every single item within the owners list. So we've got that covered. And then we're going to make sure that we don't go outside of the column count. We shouldn't based off of our input into the database, but we're just going to make sure by doing the check in the while loop. And then I'm going to just use a format string here because it's much easier than having to type out and the print or the pluses and open and closing the quotation marks. Format, an owner, index into it, and then we'll increment our R, and finally close our row. And then we'll close our table, /table, and return our HTML so that we can use it throughout the rest of the functions. Okay, we just want to make sure we did plus equals to HTML, didn't replace it anywhere. Okay, so let's get out of here, run it. Alright, we don't have any errors. I told it to return the actual column names for owners, so let's go ahead and open this file. So this is our rendering.html, and there we go. We have 2 tables of all of our information that was downloaded from the SQL database. I hope that this video has been helpful for you, and going into our last video, what we're going to be learning about is how to create these tables and make it more efficient through the use of classes. Again, my name is David Baker, and this video is brought to you by CreativeOnlineSchool.com. Hello, and welcome to Python with MySQL Database. I'm your instructor, David Baker, and this video is brought to you by CreativeOnlineSchool.com. In the previous video, we learned about how to actually create tables in HTML format and display them using Python. And going forward in this video, what we're going to be learning is how to use classes to create our databases and make our lives easier. So I'm just going to use a script that I've already started creating called SQL classes. And what we're going to do inside of this script is we're going to create a class called DataB. What this DataB is going to do is set up the parameters for actually creating our database, adding tables, and also adding elements. And then we can also view table. Again, if you need to, you can go ahead and pause the video and copy this code so that you can get caught up. But I'll explain what the coding does once I am going through those portions of the class. But to start off with, we have this init function, and what this init function does is it defines the actual startup of the object database and what we have to do. So I'm just going to make some shorthand here and do self.in is equal to database name, and then we do the same thing that we've been doing is we're going to connect to the database, and we're just going to do the host is equal to our server name, the user is equal to username, and then the password is equal to password. And then we're going to create a cursor is equal to db.cursor, and then we're going to make it so that we can access this cursor inside of some of the other functions. And then we're just going to do cursor.execute and give it some SQL to actually create the database. Exists. And use our format strings here. Format self.in. Oh. and we're going to tell the server to actually use the database, to use, and then whatever database name that we give it. Format. Okay, and so this is defining what we're going to do on the initial setup. And then what we have in the add table is we have it requiring a table name and ** columns. What this ** columns does is allows us to input multiple inputs into the add tables function and does not limit it to a certain number. And what we will have to do is we'll have to enter in to columns a column name field and then also a corresponding type, so the data type for that column, just like we have to do in a normal SQL query. And this code just sets it up so that we can make the SQL query. And we do the same thing in add element, except for the values is going to be the name of the column that we're adding values into, and then we'll actually have the values later that we will add. So let's go, and then with this view table just lets us view everything that's in the table. So let's go ahead and create a new database, and we'll create an instance of database, and let's call it Creative Online School.com, since we already have the Creative Online School database inside. And then we give it the host, which is localhost, then user, which is root, and then finally the password 9. And then we'll do newbie db.add table. So the dot method is how we access each new function inside of, if it's defined inside of the class. And then we'll just create a table called new table. And then we'll add some of the column fields. So create a column named ID. We'll make it an integer, not null, and auto increment. Since it's going to be our ID field, it needs to be unique, and it's going to be our primary key. And then we'll add another field called first, where we'll just have our first names being a varchar of 40, and then we'll have last, which will be also a varchar of 40, which will contain our last names in that, and then we'll start adding elements into it. So add element, and select the table that we want, and then we just type out, so we're going to add into first the name David, and then we'll add into last the name Baker. And then we can also do another entry dot add element to new table, and we'll just do first equals creative, and then last equals school. And then we'll actually view this database. Oh, excuse me, I need to capitalize that table, new table. Okay, this should have everything set up. We'll run our SQL classes, and okay, I spelled something wrong. Excuse me, I need to get this actual first and spell first correctly. It's always a problem. Okay, and there we have it. We have our SQL query of the table, and we have Baker, David, and school creative. So it doesn't matter which way they return the columns, but I hope this video and this entire course has been helpful for you. Now that you have a more understanding of how to create databases in Python, how to access the databases, add more elements to them, and also view the databases on an HTML platform. And these classes that we have created in this video will be very helpful if you're trying to create a lot of databases very quickly and add multiple elements to them. Again, my name has been David Baker, and this video has been brought to you by CreativeOnlineSchool.com.